Hi everyone, this is Sharan here. Welcome to my channel. Today we are going to see about binning, a concept that is most commonly used in feature engineering. Many people think that binning is something that is commonly used only when we have a numerical attribute, but that's not true. Binning can be used not only for numerical attributes, it can also be used for various categorical attributes as well. When we have a large number of classification, a large number of categories for a particular feature, and there are few categories for which there is very sparse data, which means that the occurrence of those values are very less infrequent. So in those cases, what we try to do is we try to group them all together and consider them as a category commonly, like kind of others. And of course, you know about numerical attributes, like for example, if we have age or if we have fair in the Titanic data set, we try to bin them into categories so that it can be useful in our algorithm. So the reason why we are doing binning is because binning is kind of an regularization, which means that it will try to avoid the overfitting. So when we have a lot of data, when we pass all those attributes as such to the data set, there are very high chances that we are going to overfit the data. So what would happen is the accuracy while we are training the model would be very high, whereas when we put to use those models, it will be very less. It's because there are very sparse data that is occurring, and when we put these models into test, it fails, or the prediction would go wrong. So what we do is we try to use binning as a regularization concept. That is, we try to avoid the overfitting, and hence what happens is it helps in improving the performance of the model. So today in this video we are going to see about implementation of binning using Python and using the pandas library. We are going to see the implementation for both an categorical attribute as well as a numerical attribute. So this is something that we would have covered while doing the exploratory data analysis feature engineering between day 41 and 43. But today we are going to see in detail and understand about this particular concept in detail, what is it and how to implement it. So before going into the tutorial, if you like what I'm doing here, if you are learning something new here, please click on the like button as well as subscribe to my channel. Also enable the notification icon so that all my videos reach you. Let's go into the tutorial. As you see on my screen, so binning is a way to group the data. So it can be used for both categorical as well as numerical data set, and it helps in preventing the overfitting in the model. So overfitting is something that commonly occurs in most of the predictive model. While building the model, while training the model, you will have very high accuracy rates, whereas when you put them into use, or maybe in case of Quartile, if you are participating, if you are going to submit your answers, submit your model, so then what happens is you try to realize that the actual accuracy is very less. So it's because of overfitting. So binning is a concept that helps in avoiding the overfitting. So as you see, the libraries that we are going to need today is pandas as well as NumPy. I'm going to import these two packages. So before starting, let me just clear all the outputs. Okay, so now I'm going to import the packages NumPy as well as pandas, and the dataset that we are going to use today is Titanic dataset. I'm going to use both training as well as test dataset so that we do all those changes together across both these datasets, so that you remember whenever you do any changes to training dataset, the exact same changes goes to the test dataset as well. So I'm going to execute and read the train as well as test dataset. So I'm going to show you how the dataset looks like. So this is how the dataset would look like. We have already seen this dataset multiple times now, and go into the next one. So I'm going to see in this particular dataset we have something called as a name. So this name attribute has an hidden feature within it. So it is the title. So if you see, for each name there is a title which is kind of hidden within the name. As such, name might not be very helpful in our model, but the title could be very helpful in maybe improving the accuracy of the model. So what we are going to do is we are going to just extract the title from the name, and we are going to see the distribution of it. So let me execute this. So as you see here, so if you see here, the common title are Mr., Miss, Mrs., Master, Daughter, and so on. But there are a various number of other other titles that can be found in the data set, and using these attribute as such might cause overfitting, because there are few attributes which doesn't have occur like commonly. It's very, very rare. So it made sense for us to group them all together into a category called as others, or kind of outliers. And by doing so, what happens is it helps in improving the overall accuracy of the model, like not doing the training, but the model that we use on the test data set. So what we are going to do is we are going to create a category called other, and anything that is falling outside Mr., Miss, Mrs. and Master, we are going to classify it as other. So the same can be applicable to any categorical attribute that you are working on. So you need to see the distribution of it. If you, while doing the distribution, if you see there are many values that has very, very less frequency, like if you see there are lots of ones and twos here, so if you see something like this, it's better to group them all together into a common category, and it helps in the accuracy of the model. So now what I'm going to do is I'm going to use both the training and test data set. I'm creating the mapping here. So here this is the mapping, and I'm going to say that Mr. should be replaced with 1, Miss should be replaced with 2, and so on. So here in this data set here, what I'm doing is I'm just extracting the title, and I'm using .replace functionality. So we have covered these in Pandas tutorial series. So these are all the values that can be found in the data set, the first array. The second array is the value that needs to be replaced. So for each and every element in the first array, there will be an equivalent element in the second array. So the values from the second array will be used to replace the values in the first array. So then what I'm doing is I'm going to use a map functionality, and so the mapping that we have created here in the top will be used, and all those values will be replaced with the integer categories. So this can be called as integer encoding, and that's it. So let me execute this, and we can see the distribution once again. So what happens after the data has been replaced? So if you see here, now the data has only 5 categories, 1, 2, 3, 4 and 5. So if I say 1, it is like all the titles that has Mr. is considered as 1, and so on. So these are all the 5 new categories that we have. So now the chances of our model becoming an overfit is very less, because like we are trying to ignore the values that are occurring very less frequently, and we are grouping them into a category called as others. So this is how it needs to be done for categorical attributes. And going on to the numerical attributes, like we come across a lot of numerical attributes like age, fair, salary, so on. Like any data set that you work on would have a lot of numerical data set, and all these numerical data set as well, like in order to avoid the overfitting, what we can do is we can try to group them into different classes. So here what I'm going to do is I'm going to pick up the age as an attribute. So let me show you how the data set will look like. So this is how the data set look like the distribution. There are a number of outliers on this particular data set, not so much as that we saw for fair, but still there are quite a bit of outliers for this data set. As you see here, first what we are going to do is we are going to combine the test as well as training data set. The reason behind doing this is we are going to replace the missing values with the mean value, and whatever value that we are going to replace, it should be common across the training as well as test data set. So what we are going to do is we are going to combine both of them together, and in the second line what we do is we identify all those records which has a missing value, and then what we do is whenever an value is missing, whenever a record has a missing value for age, we identify the title for all those records. So based on the title, what we do is we know for each of those title we compute the mean value. So this is what is being done here in this line. So we compute the mean value for all those titles. So whenever a record is missing age, we look at the title. Based on the title, what we do is we replace the missing value with the mean that we got for that particular title, the record with those particular title. So that's how we replace all those missing value. So now I replace all those missing values here. You can ignore the warning here. So then what I'm doing is I'm going to again split the training as well as test data set back. And then what I'm going to do is I'm going to use binning. So I'm going to create various categories for age. So this is how I split, like whenever the age is less than 15, it's considered as 0. 15 to 30 as 1, 30 to 45 as 2, and so on. So this replacement will also occur across both training as well as test data set. And now if I look at the distribution for age, so if you can see that it's between 0 and 4. So the values are being replaced with the mapping that we have given. So that's how it's usually done for a numerical attribute. So apart from binning, like here in this case binning, we specified the range. So we specified the range maybe based on, like, we have to look into the box plot, and then based on the box plot we can come up with our own range. In other cases, like if we want the distribution to be same, so then what we can do is we can make use of something called as an quartile tut. So here what we are going to use fair as an example, and then I'm going to use quartile tut. So what I'm doing here is I'm going to show you, if I use quartile tut, like if I divide the fair into 5 different categories, so that the frequency across each of those categories should be exactly same. So this is how the data should look like. So it should be split from minus 0.001 to 7.854 should be as considered as one category, and so on. So what I'm doing is I'm going to make use of that, and I'm going to divide the fair into 5 categories. So let me execute this and show you like what happens in the final data set. So if you see here, now the fair has been classified, like has been reclassified into 5 categories. We know that the fair had a lot of outliers. So by this way, what we are going to do is we are able to group them into 5 categories, and it helps in avoiding the overfitting that could happen in our model. And yeah, so binning is something that is commonly used for both numerical as well as for categorical attribute. In order, it can be used as a regularization functionality to avoid overfitting and help in improving the actual accuracy in the prediction that we are trying to make on the test, or like whatever it could be. So that is it for today. I hope you would have learned something new today. And if you have learned something new, please give a thumbs up and subscribe to my channel, and see you with another topic on some other day. See ya. Bye.